So now that we've introduced trigonometry, it's actually another story of itself because now we've opened a can of worms. Trigonometry, it's so diverse and it looks like it's a bit of a mathematics of its own kind, of which is not. But then now we're just gonna go deep and deep and deep with the topic. So far, we've spoken about two things. We've mentioned Pythagoras theorem, and then we also mentioned the trigonometric functions, which is sine. So we mentioned sine theta, cos theta, as well as tan theta and their reciprocals. So let's take it from the top. Basically, trigonometry, it focuses in the relationship of sides and angles of a triangle. As you've seen on the theorem of Pythagoras, as stated previously on our previous video. So we're looking at the relationship between sides of a triangle as well as the angles involved. To measure angles, it's very much important, or to understand how angles are measured is very much important under trigonometry. Because whenever we talk about sine theta or cos theta or tan theta, the theta determines the size of a certain angle. Not even a certain angle, it's just the size of an angle. So we use this to measure angles. We call this the protractor, not a protector for security purposes, but a protractor with an R. So we use a protractor to measure angles. To measure the angles, you just put your protractor there to be in line with your Cartesian plane like that. And then as you can see, it starts from 0. So it's 0 degrees Celsius here, and then it goes up 0, 10, 20, 30, 40, 50, 60, 70, 80, and then we have 90 degrees there. And then 90, 100, and then it goes up until 180 there. So we say it goes from 0 here up until 180 there. But we're not done because we still want this angle and we still want this angle. Since our protractor goes from 0 up to 180, anything from then we just add. When you flip it over the other side, we just add because we know that the total revolution, it should be 360 degrees. So I'm gonna put my protractor like that. So if I know that there is 180 and I know that it's going to complete another 90 degrees here, what is 180 plus 90? It's going to be 270 degrees. So there I have my 270 degrees up until it rotates to 360 degrees. So you can see it started from 0, it went to 90, 180, and 270 degrees. That's how we measure angles. So we measure our angles like this. We call this our original slide. If we have our, so if I want to measure an angle here that is formed, to can apply Pythagoras theorem. Suppose I choose this one here, it's 40 degrees, and then I construct my hypotenuse, then I would say it is formed by the angle 40 degrees. And then as you can see, the point there, if this was a circle, the point there is X and Y. Therefore, somehow this form a 90 degrees angle here. Therefore, I can apply my Pythagoras theorem. So this is how I developed this angle. So this is how angles works. So now you've seen that on our example here, we used degrees to measure our angles. Mathematicians have two ways they use to measure angles. It's either you measure them by degrees or by radians. There's a relationship between radians and degrees, meaning one can convert from degrees to radians and from radians to degrees while you're playing around with your angle. But before we go into, which is our topic for the day, conversion factor between two different types of angles, either from radius to angles or from angles to radius, which is, like I said, that's our topic for today. Before we get to the topic, I want to show what are we talking about when we're talking the relationship between degrees and radians. We say that 260 degrees, which is a revolution, is the same as 2 pi. This represents one rotation, which we call it a revolution. So this is one revolution. And then we can simplify this further. If we divide by 2 both sides, we'll get that pi is equals to 180, meaning 180 degrees in terms of radians is just pi like that. So with this conversion factor, you can get what 90 degrees is in terms of radians. You can get what 180 is. Actually, with 180, we already know 180 was supposed to be 180 there. We're just going to put this. But then how do we get 90 then? If this is 180, 180 is 90 divided by 2. So 180 is going to be 90 divided by 2. So meaning here in terms of radians, this is going to be pi over 2. This is going to be our 90 degrees in terms of radians. And what about 270? 270 is, this is going to be 3 pi over 2 because it's from pi coming to 270, we just add another half there. So it's going to be 3 pi over 2. Therefore, it started from 0 though. It started from 0. And then when it completes to 360, we know that 360 now it's 2 pi. So a revolution, when it rotates from here to there to form an angle in terms of radius, it's going to be like that. 0 pi over 2 for 90, pi, 3 pi over 4, and then 0, which completes the revolution to be 2 pi. So this is how we relate to angles in terms of radians. So now we all can see that given any question in any form, should it be in radians, should it be in degrees, one can be able to convert from one to another. But then I always say, what's the point of doing all this without an example? So we've got the following examples here. We have number 1, 2, 3. So we're going to first convert degrees to radians. The very same conversion factor works between both. It works from going from radians to degrees and from going to degrees to radians. So I'm going to show you how it's done. First, let's convert degrees to radians. So we know that 180 degrees is equals to pi. Okay. And now we are asked, number 1, to convert 45 degrees to pi. The way the conversion factor works, you see it's 100 degrees, 180 degrees is equals to pi. If you want to convert this to radians, you just make sure that your fraction of the conversion factor, the part that you want to convert to should be on the top side, meaning here we want to move from degrees to radians. Then I'm going to multiply by pi over 180, because I know that these degrees will cancel these degrees, and then I'm left with just an answer in terms of pi. And this will give me 45 goes once here, 45 goes 4 times here. So this is going to be pi over 4. So 45 degrees is the same as pi over 4. Number 2, they want us to convert 76 degrees. Again, to do this, it's 76 degrees. You multiply by pi over 180. This is going to be the number that goes here and here is 4. 4 goes 19 times here. Pi all over 4 goes 45 times here. So this is going to be our answer. So 7. Otherwise, you can just use a calculator to simplify this. If you simplify this, if you punch this into the calculator, somehow you'll get this answer, especially if you are using a Casio calculator. And then number 3, they want us to do 510. 510 over pi divided by 180, because that's our conversion factor. This is what we know about radians and degrees relationship. So therefore, this is going to give us, if you simplify this on a calculator, you will get 17 pi over 6. Here, we're converting from degrees to pi. So in this example, we are showing how to convert from degrees to radians, right? And then, like I say, the relationship of radians and degrees is you can move from radians to degrees and from degrees to radians. Now, let's see how do we convert from radians to degrees. Now, to convert from radians to degrees, just a quick reminder, on our previous example, we had the first one to be 45 degrees, and then using our conversion factor, we multiply by pi over 180 degrees, and we could see the degrees will cancel the degrees, meaning this time around we want to come up with a way to end up finding the way to cancel the pi, which is like actually representing our radians. So here, instead of multiplying by pi over 180, we play around with our conversion factor now the other way around, because now we are moving from degrees to radians. So meaning this is going to be 180 degrees over pi, like that. As you can see here, this is going to be, the pi will cancel the pi, and then it's going to be 2 times 180 divided by 3. This will give us 120 degrees. For the next one, again, pi over 6, and then we want to convert this from radians to degrees. Then we're going to multiply by 180 over pi. This will cancel that. Therefore, we'll be having 180 divided by 6, which is 30 degrees. You see, so we're moving from pi to degrees. So it results in the final degrees. So pi over 18, same thing, multiply by 180 degrees over pi. This pi will cancel that. Therefore, we'll have 10 degrees, because 18 divided by 180 is 10. So the moral of this video is now we are expected to understand how to convert from degrees to radians and from radians to degrees in order for us to enjoy our trigonometry as we are about to upload or unpack the chapter, as diverse as it is. Join us on the next video. I'm Mr. Maimane. This is Simplified RSA, the guys who makes it looks easy. Please don't forget to subscribe on our YouTube channel. Please follow us on Facebook, follow us on Instagram, follow us on TikTok. And also you can access our learning channel through Spotify. Just go to your Spotify app and search for learning channel, or alternatively you can search for simplified_RSA. And that's how you can access our